Okay. Well, welcome back, if you are coming back, to my second session of TechEd. Anyone here yesterday for my BCM session? I didn't put you all off then. That's good. Okay. So thanks for coming back, for those of you. This session is kind of I say search all up. And what I'm trying to do is, I'm kind of blasting out a few key architectural points. Which did a great session this morning on architectural decisions around search layers and that kind of thing. I'm going to go more into the individual components. So think about what the components do. Think about why the search engine today is as it is. So where we come from. How have Microsoft reached this point where the search engine is as it is today in 2013? And then look at a few admin features, some changes, some things that make it really cool, and some of the things that you can see why Office 365, which we talk about as being kind of the destination cloud, some of these features are clearly driven towards that capability to give the administrators a little bit more power, a bit more capability. I do have a couple of demos. They're kind of really basic demos, just a walkthrough of the search infrastructure and a walkthrough of some of these admin features. There is a session, I think it's after this one, search customization. No. Okay, there's a session 2 after this one, where Wayne will do a little bit more, or quite a lot more deeper digging into some of the key customizations you can do inside there, thinking about entity extraction and that kind of thing. I'll mention it briefly, but Wayne will do more. So, for those of you that weren't here yesterday, this is me. Nothing's changed. I still like whiskey. I'll still answer hard questions for whiskey. And I added myself this kind of little achievement. So I have I don't know whether it's a blessing or a stigma of having deployed the largest online search platform in the world, which was kind of cool. SharePoint search platform, should I add. So I get myself a little Xbox achievement for that. That was pretty big and pretty impressive. Other than that, nothing's changed. I still do my MCM. I still MCSM. I still have 4 kids that I throw around on a statue. And I still work for Microsoft in the CAT team. CAT team is customer advisory team. And basically, we get to deal with all the rubbish that nobody else wants to deal with. That's what we do. And we're probably the biggest advocates of on-premises SharePoint in the whole of the SharePoint product group. So you still get a lot of support from us for on-premises. So what's the session about then? I mentioned already a little bit of history, where we come from, a little bit of architecture. I'm going to go fairly deep into some of the components. What do they do? What do you need to think about? What's the impact on disk and CPU and those kind of things? A little bit of that now, more of that later. And then scale considerations and some of the improvements. So it's kind of an all-up, throw some ideas out. Hopefully we'll get a lot of questions back off you about various things. Takeaways for you. Appreciate the decisions on why the search engine is as it is today. And then understand building blocks. Think about scale. I'm going to do a session this afternoon which goes a lot more into scale and scale considerations for search. And then improvements for the admin, as I already said. So let's get started. Search evolution. Tons of search products out there. Who uses SharePoint Search? That's amazing. I'm not seeing all the hands. Who would use SharePoint Search if they had a SharePoint farm? Okay. What about Fast? Any Fast users out there? 1, maybe 2. Fast ESP or Fast Search for SharePoint, can I ask? Okay. Same. Good. Okay, so we're going to talk about that a little bit. So let's think about evolution. The search platform that we have today has been completely re-architected, as we know. Victor mentioned it a lot this morning in terms of the re-architecting of search. And we basically derived that from 2 different products. 2 products that have very different histories. So we've basically taken SharePoint Search and Fast Search. It's not quite a merging of the ways, if you like. So the Fast product that's in SharePoint 2013 is not a Fast product that's ever been deployed anywhere else in any of the Fast platforms before. It's very much was at the time an experimental platform that Microsoft effectively purchased with the purchase of Fast. And it's kind of come to maturity now, and we're able to leverage it in this version of the product. And then when these 2 got together in April 2008, which seems an awful long time ago, we've taken a long time to get to this point. Basically, they got together, they had a little baby, and that little baby is now called SharePoint 2013. That's not my analogy. If any of you have heard of a guy called Mitch Prince, this is his idea. So we've got some of the SharePoint gene pool. We've got some of the Fast gene pool. What's really cool from an architectural scale point is we've got most of the Fast gene pool, because they were really good at that capability. Anyway, so think about what we had. SharePoint Search. SharePoint Search in 2010 even was still derived from the old index server platform. desktop search platform, really going back to site server, old technology. If you look at the source code of SharePoint 2010 Search, tons of that source code is dated in the mid to early 1990s. It's old technology, okay? So we've kind of grown up a bit. When we moved to 2010, we added flexibility. We had the ability to go from 2007 to 2010 and add more search indexes, get away from some of the single points of failure with a single index component. And 2010 was quite a leap forward in that regard. For fast, loads of cool features. Content push, the thing everybody wants when they're deploying search, hopefully. But requiring lots of customization. You couldn't just deploy fast and fire and forget and leave it alone. It was basically driven around search service applications and internet-based features. If you've ever been on bestbuy.com or dell.com, those websites, they're not driven by lots of content, they're all driven by search, and they're all driven by fast in the back end. And that's what fast was really, really cool at. Yes, it was expensive, and it was expensive because it was very good. The downside is you also needed a very expensive consultancy agreement and arrangement to get it to work properly, and support was a nightmare, really difficult. So we merged them together. The decisions around why we wanted to re-architect it was basically two things. They were very expensive, very hard to maintain. SharePoint and Fast together, if you include the other kind of search features that we had, if you think about when Microsoft bought Fast, we had ESP and all the various fast search for internet and all those kind of sites. We had SharePoint 2010. We were still supporting SharePoint 2007. We had WSS search. All these things made support and maintenance a very, very expensive operation, typically 3 times the cost of maintaining a single search feature. So that was one of the main drivers around re-architecture. The second one was confusion. If you've ever sat down and tried to think about what you need from a search engine, depending on who you talk to and how ethically scrupulous the consultant was that you spoke to, you could end up with something that was way too powerful, way more expensive than you ever needed. I know lots of large companies, very, very large companies, that WSS search works perfectly for them. They don't need an expensive deployment. So we want to try and get away from the confusion. So let's go down to a single search platform that offers a great, rich experience from a search perspective, both for the client and for the admin, hopefully. But again, one kind of single truth, if you like, in terms of training people, in terms of administration, in terms of what you get out of that platform, and save us a whole pile of money internally because we don't have to support loads of different products. That's kind of the key driver. So how do we do it? A couple of things. Key thing is we need to make sure we can deal with the internet business. So Fast was exceptionally good for internet business deployment, and SharePoint Search 2013 is getting there. Make it easy to install. Remove all the open source stuff. For those of you that dealt with Fast, dealing with things like the Fast open source, bits of Apache, bits of this, bits of that. The license agreement for Fast Search for 2010 had about 27 different open source agreements included with it. Not ideal. Certainly not something we want to then go and sell as a solution. And make it Exchange and cloud friendly. So those of you that don't know, Exchange 2013 also includes SharePoint search engine inside it. It's the same engine. So we've kind of re-architected again. And make it cloud friendly. So Office 365, make it easily consumable, make it so that your site admins in the cloud can easily modify and maintain a search service without having to continually go back to the search admins and ask for requests and changes into central administration. So that's kind of the key drivers. And what we ended up was this guy. More complex than either the two previous solutions. Some limitations. So we have our components in here. I'm going to talk about these individual components in a few minutes. So the crawler comes from SharePoint 2010, plus some changes. The rest of it is either net new, completely net new, or it's fast derived. So things like the concept of content processing, the concept of query processing in the way it's done today is very much in the way the fast search engine did it. The key thing that we've kept from SharePoint is really the crawl engine. And then there's the analytics piece. The analytics piece is completely new. Any of you that tried to scale SharePoint 2010 analytics, the recommended guidance was once you got more than 50,000 objects in your SharePoint farm, you actually turned analytics off because it became a performance hog and killed your farm. 50,000 objects is nothing in anyone's farm. I don't care how small your farm is, it's nothing. So in the new analytics engine, we can scale to potentially hundreds of millions of analytics events without any degradation of service. So, One thing I want to point out, anything in here that's changed, I've added this little icon here. So that as you go through the slides, anything that's net new will be called out with a little link to one of these change ahead icons. So we're going to look at the components in the databases. Effectively, Victor talked about the layers and the tiers of deploying search. We're going to talk about what those individual components actually do. And feel free to shout if you have any questions. So the first thing to note is SharePoint Search has two system services. So in SharePoint 2010, if you're familiar with that, you'd have seen lots of MS Search Exe floating around. Everywhere you deployed search, basically, everywhere you enabled the search service. In 2013, we have this new thing which is called Node Runner, which is we have our host controller service, which spawns multiple Node Runner services. And those Node Runner services are where all these new features arrive. The content processor, the query processor, the index. They live inside a new architecture. Won't be new to the fast guys, but they're new from a SharePoint perspective. The host controller service is effectively the thing that's going to spawn everything from a search engine in terms of capability. So we have the content processor, index, query processor, analytics, and search admin all running inside this Node Runner process. Key thing to note, if search is down, make sure this guy's actually running. So it's not a case of just finding the node runners. Make sure the host controller is actually running as well, or you run into all kinds of problems. As you scale your search and you get towards, I mean, I don't know how large search indexes we're talking about, but as you get towards very large search deployments, as these services start, they can tend to be very slow starters, and search can be difficult to get running as things scale. We're trying to fix those issues as time goes on. But just beware, if you get issues with search not starting, sometimes it's easier to go in and start looking at manually restarting these services. That's just kind of a side point. And then the old SharePoint Server Search Service, the MS Search Exe that you'll be familiar with, the MSS Daemon that you'll be familiar with. This is basically the crawl engine. So the Search Exe is the thing that's orchestrating the crawl, the thing that's controlling the crawl. And the daemons really are sacrificial processes that are spawned by the search engine, literally to go out and collect content from the various content sources or repositories. The reason they're sacrificial is that we don't know where they're going to go. So they could reach out to a SharePoint farm, they could reach out to a file server, they could pull an enormous document back that causes the process to crash. The last thing we want to do is take down the whole search service, so we use these sacrificial processes. And if one of these fails, we log an event, we create a new one, and we move on. There's no kind of, it's a way to preserve the capability of the service. Startup type for this guy is going to be manual. So the MS Search Exe process is only started on demand from basically a request for a crawl. So it's not going to be running permanently. If it is running permanently, then you've either configured continuous crawl, which is something we'll talk about later, or you've got a problem, basically, with the crawl not stopping. So just what I want to do very briefly, who of you have seen 2013 search? Okay, so there's still somebody that haven't. So what I want to do is really just drop into the search service application, just to give you a little bit of an overview of where things are. So as with all, let me go back one. As with all search services, as with all service applications, as Victor showed us this morning, we've got our search service application here that's connected to from central admin, from the web applications, sorry, from the service applications. And inside here, from a search admin perspective, there's a whole pile of features we can do. So we've got the admin service. Is it running? Yes, it is. You don't want to ever see that saying stopped or failed. What's the crawler doing? In this case, we're doing nothing. And the reason it's doing nothing is because I'm not crawling anything. And then we can see a bit of information about recent crawls, a bit of information about recent query rate. And the last thing you want to see here is errors in this area here. Okay, so that'll instantly denotes you've got problems. And the search service is pretty good at reporting errors. As we go down, we see our search application topology. This is a very, very simple deployment on one server. We've got our admin, crawler, content process, analytics, query processing, and index partition all on one machine. Would you do this in real life? Almost certainly not. There is occasion when it might be relevant, if you've got a very, very small deployment, but it would have to be a very small deployment. And then our good old favorites, databases with GUIDs on. Not the nicest thing in the world, but you see in SharePoint, for those of you that have seen SharePoint 2010, the databases are very different now. So we have an admin DB, we have analytics, crawl, and link. The one that's missing is the property DB. So in 2010, you would have had a property database that contained all the metadata that was discovered during search. That metadata is now added to the search index on disk instead, in the same way it was done with FAST. One thing that's missing, for those of you that would be familiar with 2010, so some of you in 2013 search, have you all seen 2010 search? Okay, lots of nods but no hands. 2007 search? Who hated 2007 search? Okay, everybody should put their hands up. Okay, so it's very different from that as well. But one thing that's really clearly missing from here is there's no button that says modify topology. So one of the key things that I'm going to talk about in this session this afternoon is how to modify the search topology using PowerShell. And we're going to do a big scale out across multiple servers. So from an admin perspective, we've kind of taken away one basic functionality. Other things in here, very simple things that we have. Our diagnostics are now more intuitive. You don't have to go clicking on admin reports, search reports, and then kind of drill down into various things. So we've got our crawl log, crawl health reports, and we're going to look at these in a later demo. So this was just really to give you an overview, just a quick look at what the search interface looks like. Very familiar from a 2010 perspective, but also several changes. So looking at the components then. I'm going to walk through these basically one at a time and just tell you what they do and tell you why they're important. So the admin component is critical to the whole system. It's basically the heartbeat. If you think about the admin component and the admin DB, you can think of them as working together, and they're equivalent to the config DB of your farm, if you like, but from a search perspective. If you lose the search admin DB, you lose your entire search topology. You lose the ability to continue to search. The admin component itself is a node runner exe process, and it's the process that your admins are basically communicating with when they're making search changes. So if you go in and modify the topology, if you go in and change a content source, anything that you do inside search, you're all communicating to this guy. It's also responsible for all the health metrics of the search engine. So having the search admin component available means that your search should stay up. And in fact, we can deploy multiple admin components as well, which is something we couldn't do in 2010. In 2010, the admin component was theoretically a single point of failure. In 2013, it isn't, and you can deploy up to 3 of them. And the recommended guidance is that you would deploy at least 2 for high availability. The search admin DB, the one key change here is that we no longer store ACLs in there. In 2010, if your admin DB became unavailable, you lost the ability to query because we couldn't security trim the content. We couldn't security trim results. In 2013, that's not quite the same. So the admin DB is still critical to the functionality, but it's not critical to security trimming anymore because we store the ACLs in the on-disk index. Other than that, it's pretty much the same as 2010. From a crawl component perspective, this is where there's been an enormous change. So in 2010 and previous versions of SharePoint Search, the MS Search exe process, or the crawler, was responsible for much more than just gathering content. It wasn't just a case of going out, collecting content out of SharePoint, collecting content off file shares or the web. It actually did a whole lot more, including document parsing, word breaking, linguistics processing, and it was a fairly heavy component that could consume a significant amount of memory and certainly a significant amount of processing on the box. In 2013, that's changed. So we no longer do content processing in this guy. All this process does is go out, grab a document and a little bit of metadata, drop it down onto a file share on disk, and then make it available for the content processor to index. As a result, they become much more aggressive, potentially. So Victor mentioned about search targets earlier. If you just deploy a couple of these guys and let them go rip against your farm, the chances are you'll potentially do a denial of service attack on yourself. So just be careful. And there's a valid story to that. I did that. Anyone familiar with the BBC in England? Yeah, the British Broadcasting Corporation. So this was with SharePoint crawlers. They asked me to go and deploy an environment and crawl their entire intranet with SharePoint Search, and they wanted to go as fast as they possibly could. So I warned them, I gave them the caveat, be careful, denial of service is fairly serious. And they took down their entire intranet with a search crawler. Easily done, just be careful, as Victor was saying earlier, test things. And they can be very aggressive, very, very aggressive. And you can throttle them back, there's what we call crawler impact rules where you can reduce the amount of threads that this guy has, you can reduce the impact that this will have on the farm. The key message being document parsing is the thing that's missing. The crawl DB, on the other hand, still there. We've got a lot of changes in crawl, which we're going to talk about shortly. We don't have the concept of anchor processing. Has anybody kind of wondered why your search wasn't completing, your crawl wasn't completing? You go and look in the search admin interface and you see it sat there saying either anchor processing or waiting to complete. You get that and it sits and it just churns away forever. And then eventually it might stop. Well, that's what we call anchor content processing. And it's basically the search engine finding all of the connections between documents and pages and links and processing them into the search index. And it takes a long time. And a typical search corpus that could be, say, 5 million items can easily generate 100 million anchor connections. And that takes a long time to process. And in 2010, it was painful because it was done through the database. And because it was done through the database, it was synchronous, which meant we couldn't actually go on to complete another crawl until this thing had finished. And it became a very intensive, very painful process. In 2013, we've taken that away, and that's now done by the analytics engine in an asynchronous process. So from a search DB perspective, there was guidance on TechNet in 2010 that said you need to have 7,500 IOPS on your spindles to be able to support a search DB. That's reduced significantly now. Why is it reduced significantly as well? Is because we've also changed the crawler architecture. So in 2010, there was a limitation. Did anyone know what the maximum number of items on a web application was in 2010? And it was dictated by search. And it was actually 25 million items, which is a lot, I appreciate. In SharePoint Online, it's not a lot. Right? We have search indexes running into the 100, 150 million items. And in 2010, we had some customers who were trying to do that in one web application, which meant one crawl database, because the affinity between crawl databases and web applications was a one-to-one relationship. So the anchor processing became worse, the crawl time took longer, the databases were reaching 800-900 gigabytes in size. In 2013, we've changed all that, and we can now support what we call multiple crawl DBs on a single web application. It's kind of a concept you need to get used to. So what we've basically done is we can now stripe our crawling capability across multiple databases. So in 2010, we had this scenario where one web application effectively could only be crawled by one DB. So if this DB failed, you were dead in the water. And the maximum number of items you could crawl in this DB was this 25 million. In 2013, we've changed it all. So we can now stripe our crawl across multiple databases. We're not limited to what we call a single crawl queue inside a database. And because all DBs can now talk to all crawl components, and all crawl components can now talk to all web applications, the scalability improvement here is enormous. And this is the kind of thing that's going to help us support in the future going towards the 200 million, the 300 million, the billion item indexes that are really important for web-based content. So it's a major architectural change, worth understanding. These slides probably don't do it justice. It's worth reading up on it, or feel free to reach out. But it is an enormous difference, especially for large environments. In terms of the processing then, the key thing that's different, full crawl remains the same, incremental crawl remains the same, a few minor changes. The key thing is continuous crawl. So those of you that deployed 2013 are using continuous crawl. I know one person is. Anyone else? Has anyone even thought about using it? Okay. Why didn't you use it? Why not?
Because we don't have 2013 yet.
Okay, I fell into that one. So it's a really cool feature. Basically, if you think about incremental crawls, so one of the things that SharePoint has traditionally suffered from in terms of search is content freshness. And incremental crawls don't really cut it. You could cut your incremental crawl times down to, let's run a crawl every 5 minutes and hope that helps. The problem is, if somebody comes along and then, let's say, for example, they go to the web application interface in central admin and they decide they're going to add themselves with read access or full control to the entire web application via a policy. That has a catastrophic effect on search, because effectively what happens when you do that is it ripples down every single item inside the whole web application and modifies the ACL. When search picks that up, it's a deep change, right? So if you've got a million items on a web application, that means we've got to go out and discover a million changes inside search. Even if the document content hadn't changed at all, because the ACL's changed, we have to crawl everything. We don't just crawl the content, but we have to discover the security. And that leads to this kind of scenario. So where you might like an ideal situation where you're doing an incremental crawl every 15 minutes, and it kicks off after 15, 30, 45, 60, what you actually end up with is these extended processing changes. So your incremental crawl, instead of being 15 minutes, might take 4 hours. So the guy that added the news article to the intranet and is expecting it to appear for everybody via a search content discovery suddenly finds he has to wait 4 hours for the index to recycle back and discover that item. Fine in some scenarios. That's not good if you're in a regulatory environment. So we have some customers in online dedicated space who are pharmaceutical companies. and they have real issues with publishing specifications and documentation to their internal people. And sometimes new drug discovery, it has to be available online ASAP, because when you're trying to do drug discovery, it's an expensive process. A few hours delay and somebody repeating work that you've already done can be extremely expensive and extremely painful. So we have to get past this issue of extended crawls. The other scenario is if you've got a very long, a very large search index, and you need to maybe make a managed metadata change. Not managed metadata, sorry, a managed property change. That requires a full crawl, right? That can be painful. One of my that big search index I was talking about earlier, that kind of my achievement, if you like, that takes 807 hours to do a full crawl, right? When you initiate that full crawl, that means that anything new that's added to the corpus while that crawl's running doesn't get added until after 807 hours into the search index, and that's just ridiculous, okay? It's a poor situation to be in. So we introduced this thing called continuous crawl, and continuous crawl means we can now do, it's not really a crawl that's just running all the time, it's multiple parallel crawls. So we basically can kick off a new crawl even down to every minute if you wish. That's a bit mental. You'd really do it like every 15 minutes is the default, maybe drop it down to every 5. In Office 365, we do some every 4, depending on the size of the farm. So this gives us a slightly different scenario. And it means that when we start our crawl, if we discover deep changes, and for example, with cycle 1 here, someone's made a change, and our crawl's pushed over 30 minutes. This means that if we were running a cadence of 15-minute incrementals, the next incremental isn't going to start here, it's going to miss and start there. Okay, so we miss an entire search cycle, and that could be important. 15 minutes is not a long time, but if you're running every hour, sometimes it can be a painful experience to have. With continuous crawl, however, we just start a new one anyway. And it's effectively the same process. We don't spin up another MS Search crawler. What we actually do is there's basically, if you like, a journal or a log that's basically saying, this is the crawl. I'm starting a crawl now. If we look at cycle 1, a crawl will start. There'll be a cookie that basically is written to the database that denotes the start time. And then when the next one starts, after 15 minutes, which is the schedule here, that another cookie is written, and all the changes since the last one, even if it's not been complete, are then collected by the search indexer. So we're maintaining this kind of continuous log, if you like, of every 15 minutes of changes. And the engine can run, even though the crawl hasn't finished, a new crawl can start. So it's just this continuous kind of loop, if you like. It's the same process, but multiple parallel crawls. So it means that content freshness in effectiveness, or the effectiveness of content freshness, means we can bring it down to usually within minutes. I don't know, Victor, you do continuous crawl. I don't know what your freshness is like, but we can get our crawl freshness down to within 1-2 minutes easily of a document being added, just by enabling the continuous crawl capability. Question?
Is there a substantial performance hit to do that?
Yes, that's the trade-off, right? So you've got this search process that's running continuously. You're going to be getting multiple hits to your web front ends. It only works for SharePoint content sources. So basically, you're exposing your environment now to continual crawling, which if you've not built it right or scaled it right, can be a problem. So yeah, be wary of it. Yes, it's a great feature, but it can introduce an issue. You can have a bag for that question. That's a really good question. I won't make you get up.
Thank you.
Okay. The downside to continuous crawl is there's no retry. So if we try and crawl something and it fails, if we attempt to connect to a document and we can't download it for some reason, the search engine won't go back and retry. Okay? It gets logged as a failure, and then every 4 hours we do a sweep, effectively, if you like, that then picks up those changes to a regular crawl. So that's kind of the continuous crawl is a bit more complex than that, but that's kind of in a nutshell, a new feature that we have, and I'll show you how to configure that in a later demo. From a content processing perspective, content processing and I say LinksDB, they're kind of intertwined. The content processing feature is new to SharePoint, traditional with fast, and this is the piece where we're going to take our documents, effectively rip them to pieces, pull out the metadata, pull out the keywords, get the ACLs, get all the kind of abstract representation of that content, and convert it using iFilters, using what we call format handlers in 2013, and basically make it into a form that can then be written into the on-disk index. So we'll make it available for search. At the same time, we also make changes and write information to the LinksDB. So that anchor processing process I talked about earlier, or the anchor crawl, if you like, what we call it, that is now done through the links DB by the analytics engine. So instead of having the search go out and crawl, complete what we call the physical crawl, then have to process all these anchors, this, if you like, virtual data that it's collected, that's all done through the links DB now. So the links DB can grow fairly large, and we process events and process data through there. The links DB is also where we store user-driven events. So when you go and click on a document, when you're just using search generally, there'll be an entry added to the links DB. And then that goes into the search engine through the analytics processing and becomes part of the index. So when we look later at query enhancements, we'll see that it's your own experiences within SharePoint can have a dramatic impact on the search index as well. Other things it does, so generates phonetic names. If any of you deployed SharePoint 2010, you notice one of the prerequisites that got installed there was the speech server, the Microsoft speech server. That's now gone. So we've abandoned the requirement on speech server and written our own phonetic processing engine inside the search engine itself. So it basically does everything. This is a fairly heavy component to have around. The analytics piece is the net new piece. So here we're talking about a purpose-written analytics engine that not only works with search in terms of discovery and work from a links perspective, but it also processes all of your data that you're doing as a user inside SharePoint. So if you're doing a search, you click on a link, or you click on, say, the third item in a set of search results, that data is added to this links DB and processed by the analytics engine. If you're just a casual user, not using search at all, but you're browsing through site collections, opening documents, clicking on wiki pages, whatever you might be doing, everything you do is added to this event store and processed by the analytics processing engine. So you can't get away from it. Everything you do is being effectively tracked by the engine. And that means that we can do things like, well, okay, if you search for a piece of content, you find a result you like in the search results, and the hover panel pops up, we can show you related content that other people have been to that's kind of similar. So it kind of improves the whole search experience. And it's all driven by this analytics processing component. The query processor is kind of the key thing. Without the query processor, you can't really do anything from a search perspective. And Wayne's going to do some customization work with the query processor later. Fundamentally, the query processor is, if you like, the piece in the middle between the SharePoint server, the web front end, and the search engine that will go out and take your keyword query that you submit it to the search engine, bring the results back out the index, compile those results in a way that's been dictated by things like query rules, things like query transformations, and then ultimately present those results back to the web front end for presentation to the end user. It's also the piece that does the security trimming as well. So it's going to decide, usually, it depends on how you configure security trimming, but it's a piece of the search engine that's doing a lot of heavy lifting in terms of presenting results back to end users. In terms of what it looks like, that's very simplistic. In the middle, we have two services actually inside the query processor. There's this query and site setting service, and there's the query processing component. The query and site setting service is, last time I got asked what that service actually was, it's a little bit difficult to describe. But if you think about when you're in site collection administration, you can configure things like search visibility. You can make changes to search schema changes. You can configure query rules and query transformations and result sources. And that's the actual service that goes and decides which elements of those configured functions you actually want to use before you present your results back to your end user. So there's kind of two sides to it. And then when we come to look at the index, everything's kind of changed. So 2010 index, we had this ability to scale out to what we call multiple partitions. So we could split the index up, something we couldn't do in 2007, for example. And that gives us kind of benefits in terms of scalability, benefits in terms of performance. In 2010, we could also have multiple partition copies on a single machine. In 2013, you cannot do that today. So one thing to think about if you're scaling out, I mean, anyone got more than 10 million items in a search index? One. 5 million? Okay, so we're relatively small in terms of size. So from a partitioning perspective, a scenario, if you're running, say, for example, 5 million items as a kind of larger search platform, you're really going to be looking at this kind of scalability here, where you've got two replicas of a single partition. We can support 10 million items per partition. So as we scale out, you'd need about 2 servers. And really, the two servers will be required for high availability. And we do a continuous kind of, well, replication, journal-based replication between the two replicas on a single partition. One thing to note with SharePoint 2013, one thing we've changed in terms of how we write the index, we never change anything in the index. So as you're continually crawling content, what we're actually doing is overwriting everything, or overwriting, What we're actually doing is we're creating new indexes all the time. So we're constantly generating new content on disk and removing the old content through what we call the master merge process, but that's kind of a little bit deeper. From a partitioning perspective, the key thing to remember is any one partition can support 10 million items, and for HA, you need 2 copies of that partition. That's kind of the key message, so depending on how big you scale. If you need 100 million items, you need 10 partitions as a minimum. From a scale-up perspective, in terms of scale-up and optimization, really there's 2 ways to scale. So think about all the components we've just had. We've got crawl components, query components, indexes, analytics. And we really, when we think about how we're going to deploy that search engine and whether we're going to grow it larger or we need to grow it larger, we can scale in 2 directions. Probably a common one, if you're looking at very small farms, is just more horsepower. Right? Add more RAM, add more CPUs, modify your physical architecture, and that will get you so far. From a HA perspective, or if you're looking at you want really distributed queries, and there are some changes coming along down the line with SharePoint 2013 that give real benefits to scale out rather than scale up. So scaling out can be an added advantage as well. And there's a number of ways to think about it. What do I need? Do I need more CPU? Is it content processing I need versus more indexes? If I'm growing my content but not growing my query load, then I need more partitions. So it's a different message, a different story. If I'm looking at just query load versus content, I might have a very small corpus, but I'm attached to the internet and generating millions of requests or hundreds of thousands of requests an hour, and it's a different story in terms of where I need to scale. But the key message being we can scale in both directions at any time, or either direction, should I say. And you saw this slide if you were in this session, Wix's session earlier. It's kind of a crib sheet. We do try and keep on top of this and change it as time goes on in terms of what you can and can't put together. From a joining or deployment perspective, what we're really trying to say is anything that's got 3 stars, you really wouldn't put with another component that has 3 stars in the same column, because you're just going to introduce resource contention. 3 and 2 is okay. 3 and 1's better. 3 and nothing is better still. So this is kind of a way to distribute your architecture. From an optimization, in terms of thinking about what can share nodes, so Victor showed this fairly simply this morning. Really, content processing and analytics they're pretty good kind of bedfellows, if you like. They'll live together quite happily on the same physical machine or virtual machine. Search admin and crawl. In fact, search admin will sit quite nicely with most other components because it's a very lightweight processing component. And this afternoon, we look at the actual search scale and do real search architecture. We're going to look at individual things like what's the recommended number of CPUs, what's the recommended amount of memory, processing cycles, and that kind of thing in terms of where these components are. So this gives you an idea for what you can mix and match. So thinking about the tiers of architecture that Victor looked at earlier, we can mix and match these things around. If you've got a very small deployment, maybe less than 500,000 items, you could theoretically run these all on the same machine. You'd want a fairly beefy machine, but you could do it. We're not saying you have to scale it out in this regard. From a sizing and load perspective, I'm not going to talk through this slide, these next couple of slides, but really this is kind of data that's available on TechNet. It does change over time. So what I would recommend from a search sizing perspective, if you're going to go and start looking at search scale out and search architecture, or specifically for new deployments, go and get the latest guidance. Because it's almost certainly changed since the last time you looked at it. Things like IOPS for DBs, things like disk sizes, how many items you're looking at. So we tend to quote in units of 10 million, which by the sound of some of the search corpuses that you've got out here is probably too big. But it gives you an idea of what the upper limit is and what you can achieve with a relatively minimal deployment of search. Search admin DB is kind of an interesting one. If you were familiar with SharePoint Search 2010, the admin DB load could be fairly considerable, especially when you're doing high query processing. In 2013, that is a very different configuration, a very different situation. And by and large, it's, some of the data remains the same, but a lot of it has changed quite significantly. In terms of size then, when we look at guidance for size, again, I'm not going to go through all this individually, but we're looking at how many components you need for different sizes. It sounds like everyone in the room is under 10 million, so you're very limited in terms of what you need, and mostly these components will be available for high availability. So do you need one crawler or two? Well, I might have two because if one fails, I want to be able to continue to crawl. Do I really need two? Well, it depends how critical search is. What's your SLA on search? That's kind of the key message there. From a query processing perspective and from an indexing perspective, the chances are you're always going to go for two because querying tends to be the thing that people complain about. If you don't get crawl for a little while, okay, depending on which business you're in, you can live with that. If query goes down, it's where people start complaining, especially in the new world of, as Jax pointed out yesterday with web content management and search query web parts. Most of your internet content and your publishing content could very well be search driven. And if you can't query, you lose the ability to really deliver your content to your users, never mind the ability to search for results. So having multiple components in the query processing layer and in the indexing layer becomes quite critical. And it's not really just a case of thinking about scale and size. And then a few things about actually scaling for performance. So we mentioned size. If we want want to scale to more than, say, 10 million items, we need additional partitions. We need additional index components. But what if I want to scale beyond 10 queries per second? What if I want to crawl at, say, or query at 100 queries per second? In an internet search environment, that's something I'm going to really need to think about. So having additional query components, having additional index replicas means I can surface or I can serve additional queries or more queries per second through my entire search platform. So really, it's a performance thing. From a crawler perspective, in 2013 search, we really don't recommend you need more than 2 crawlers. So from a crawl performance perspective, any more than 2 crawlers will tend to go back to this denial of service situation. And you can really cripple your entire environment by doing that. The 2 is about as much as you need. Again, these numbers, this guidance will slowly change over time. So it's worth it if you're going to deploy a new search service application or deploy a new SharePoint farm that's going to consume search, which most of them will, always go back to this guidance, always get the latest numbers. So that kind of concludes part 1 of the whole thing. Brief history of time, a little bit of look at services, components and databases and sizing. The session this afternoon will go a lot deeper into the sizing content. What I want to do now is really look at admin changes. So from a search administration change perspective, really looking at things like what's changed in the UI, what do we need to do in terms of power and capability that's been added to the end user and things that they can do. So yeah, a bit of a noddy diagram. It's not a SharePoint server, but there's a number of things in terms of SharePoint. Customization is going to be covered by Wayne, but certainly in terms of things you can do in the search UI to improve the experience for end users and make the admin life a lot easier. So let's go into the admin and let's see what we can find. If I can get this to work. Okay, so this is where we were before. And really looking at things like the central administration, farm search administration, and overall features. So I'm just going to go through them again one by one, but this time we'll go in a little bit deeper. We'll look at making some changes and we'll look at seeing where things are. So from a farm search administration perspective, these are things that are going to globally affect your farm, and they're going to be things that you'll generally set once and never look at again. So the key thing, a couple of things, proxy server. Rarely I find that this needs to be set. Usually, especially if you're in an internet scenario, it's very rare to find a proxy server being needed. But occasionally you would need to set it, and you can set up things like, the connection. If you need to set authentication for your proxy server, you need to start looking at web config changes to do that. But typically, proxy servers, I very rarely find they're needed at all. Timeouts can be important. So sometimes if you're crawling content that's in a very latent network, typically SharePoint search going back a few years, for example, the Microsoft deployment of SharePoint search a few years ago, we used to crawl our entire global WAN from one single point. And that meant we were crawling repositories in New Zealand and Australia and Singapore, for example, is one of our main repositories in this area. 60-second timeout sounds like a lot, but it really isn't. So you might want to think about configuring and changing that. If you've got slow file shares over the other side of the world, for example. So be careful about configuring these. And these are, the UI here gives you options to change them very simply. In PowerShell, you also get a lot more changes you can do. So you can change individual repositories. You can make changes to timeouts. You can do changes to things like how many items should I pull back from my individual repositories in any one single request. Or when a crawler connects to SharePoint, how long should it wait before it sees a timeout, and how long should it wait, or how long should SharePoint wait, should I say, before it sends content back to the crawler. So it's kind of a two-way thing. How long does the crawler wait, but how long should SharePoint wait? Because SharePoint has to batch information up, send it back to the crawler for processing. You don't want it hanging around too long because it tends to experience like search fails. So you can configure it in the UI, and you can do a lot more in PowerShell. Ignore SSL warnings. We, of course, never want you to turn that off. Right? SSL is important. We want to make sure that the repositories you're connecting to are authoritative. Sometimes, though, there's no way around it. You just need to, if someone's gone and configured an environment that's SSL protected with a self-signed cert, for example, for testing purposes, you might want to go and set this. Rather than import a self-signed cert and trust it as a global root, the last thing you want to be doing is that. So going in and ignoring SSL certificate warnings can be fairly useful for testing purposes, but not for something you want to be doing in production. Certainly not if you're crawling a repository that you absolutely don't trust. And then this obviously takes us into the search service application itself. And so we're back to where we were before. We can see the admin status. We can see the crawler background activities. Nothing going on here. I've only got a small corpus, 301 items. Here I can change my default content access account. If you change that on a production or any system, you will initiate a full crawl, okay? Because you're changing the access that the search engine has to the content. So it might be now that the account you're using is actually excluded from certain areas, and therefore you don't want that in your search index. So by changing this, you will initiate, the next crawl you do will automatically be a full. So just be wary of that. Make sure you've got the account set up front first. Other things, so email address for calls, fairly straightforward, nothing really in there. Proxy server, we've mentioned already, that will take us back to that initial page. Things like search alerts and query logging. So query logging, these are both on by default. So search alerting is fairly useful if you're subscribing to search alerts. You know, you issue a search, you subscribe to an alert, so if those search results change, you'll get notified by email that there's been a change to your search results and something new has been discovered from your queries. That's useful to have on. And obviously query logging. If you turn query logging off, you're losing all the analytics capability. So all the improvements that you get from a search perspective in terms of events get lost, and you lose the ability to investigate things like queries per second and query performance, which can be quite critical in some environments. And then this thing, the Global Search Center URL, is very new to SharePoint 2013. Effectively, it allows you to configure a default global search location. So if people are issuing search queries and there is no specifically targeted URL to go and surface those queries against, this gives you the ability to set a standard, if you like, a company global URL to go to for searches. Architecture we've seen already, database is down here. So some of the things I want to kind of draw attention to really are more down the left-hand side here. So things like the crawl log and some changes in here. Let me just move across. So this is showing fairly straightforward. We can see times of last crawls and average crawl durations. That's actually quite low. Well, it's quite high for 300 items. We can see successes, warnings, errors, etc. If we go and look a little bit deeper into the crawl log, so let's say, for example, go and look at the URL view. First thing to note, if you're familiar with 2010 or fast search for 2010, the response of the page is quite quick. And the reason being for that is we don't go and try and mine all the crawl logs and show you everything, show you kind of a default view of everything. So we do give you an option to configure it before we show you any data. And you can simply type in the URL you want to find, or we can just say, show me everything from a particular content source. And in here, we can see our URLs. This is kind of the same. In fact, that's broken. But we're getting the similar information that we saw with 2010. But there's even more data we can look at in here. So if we look at things like crawl history. Crawl history was something we had in 2010, But what we didn't have was a lot of this information over on the right-hand side. So we had things like successes, errors, top-level errors. So who can tell me what a top-level error is? Okay, all right. No, so a top-level error is basically where you've tried to hit a web application or you've tried to hit the root of a file share and you've been denied access or you've been blocked. It's not been able to be crawled for some reason. And that will manifest as a top-level error, which effectively means, as Wayne said, it's a bad one, because typically it means everything underneath there has not been able to be crawled either. There can be two consequences to that. It can be that it's something suddenly broken, and now you're going to jettison all of your search index because you can't reach that content anymore. Or it can be that something, you've not been able to reach something, so some new content that's needed to be added to search can no longer be added. The things on the right-hand side that we're kind of interested in, crawl rate's important. When we're seeing things like documents per second, it's fairly low in this environment. But you're looking for, as a search admin, you'd be looking for patterns. And why has my crawl rate suddenly dropped, for example? Has something changed in the environment? My crawl rate might drop because someone goes and makes a major security change, for example. So you're seeing things like that. Crawl latency, repository latency. So we can see here, I'm crawling exactly the same content, okay? But the repository the latency on a C, I've started continuous crawl running. The repository latency suddenly shot up to 8 seconds or 7,000 milliseconds, which may indicate a problem. As a one-off, it's not so much of a concern. But if you started to see a latency that was typically low to begin with, and then over time it gets worse, then something's wrong in the environment. You could be under network pressure, it could be a disk issue, it could be a crawl, DB problem, and it kind of exposes information that becomes useful to the search admin. If we look at other things like the crawl health reports, we can start to look a bit more deeper at these things. So in this particular example, I've had a crawl running here that's typically doing a full crawl every 30 minutes and an incremental every 15, and then I've started continuous crawl going over on the right-hand side. And if I zoom into some of this, so if I just make this a bit more visible, if I do 2 p.m. to 4 p.m., actually, I don't want to do 2 p.m. I want to do 12 to 2. No, that wasn't a good example. Let's do... Sorry, I should have wrote my dates down, timed down so I knew where they were. No. Oh, that's why. There we go. Sorry. Take the 24 hours out. If you can remember what day it is, then you're all right. And we still see nothing because I've gone ahead of time. Sorry, folks. Let me give me a second. It doesn't help when your VMs are still in English time as well. No, okay. Let's ignore that one for a minute. I'm going to go back. Let me just reset that. So I'll be sensible and look at a real time. So 11 at 4 p.m. and let's go to 11 at 5 p.m. Make it a bit more sensible. Wait a bit, 11. I will get this right, I'm sorry. There we go. So what we can see here is information from the crawlers, which are basically saying what type of content have we discovered. And depending on how it's color-coded, it means something subtly different. So we can see items that have been modified, not modified in terms of no changes. Security only can be quite interesting. So if you're seeing extensive security changes in your environment, you'll see masses of this red hatched in here. And this is a place to go and look. So as a search admin, these reports are critical to kind of maintaining the health of the environment. Other things like retries and errors can also be important. If you get multiple retries, it can basically mean that you're connecting to an environment that can't deliver information fast enough, or it's generating lots of errors. So as you continually get retries in your search environment, sometimes you may be crawling it or trying to crawl it too fast. So think about throttling back the crawler if the source can't deliver the content to you quick enough. Other reports we have in here, we've got the the crawl rate per content source. So this can be quite useful. If any of you forget to put antivirus exclusions on your crawl index, on your search indexes, you'll see appalling performance in here. The crawl rate will drop. You'll start to see a very stuttered experience as well. As you get a crawl, then it stops, and while the antivirus engine scans everything, and then it crawls again, you'll get this kind of spiky experience. So just be wary of things like that. AV is critical to the performance of search. Some of the other things, like crawl freshness, is a brand new one. So in 2013, we have this concept of crawl freshness. We get a nice graph across the top showing us what our aggregate freshness is. We can see how much of our content is fresh within 10 minutes, 30 minutes, and an hour. I've actually killed the crawler now, so it's kind of going off time. But you can see that with 100% of our content is fresh within 4 hours. So we crawled it, all of it, within the last 4 hours. And if you've got crawl continuously running, either continuous crawl or frequent incrementals, these numbers will drop. And ideally what you want is the numbers where it's less than 10 minutes, you want high percentages in that space if you're in that kind of business where you're looking at really fresh search. And the last thing you want is just like 100% out here and nothing down here, because that's just pretty poor. And it's, the graphs are nice. They show you things. They can, people are complaining that they're not getting their search results they expected, or they published a document 10 minutes ago and why isn't it in the search index? These can give you a clue as to where to go and look. Other things we get that we didn't have previously, you would have to fire up performance counters for, is things like CPUs. This is kind of going off. Let me just see if I can minimize this. Make it a little bit easier to see. So we've got things like total memory usage, total CPU usage, so we can kind of get a gauge for how the search platform is running. Memory usage by process. So we mentioned about these node runners and MS search processes. This gives you a good idea for how much memory they're consuming. So you get really high spikes in here. You're going to get, it's basically telling you need to scale out and start taking some processes off those boxes and move them somewhere else. Really, really useful reports. The other reports we have are things like query reports. So we can see, this is very simple, showing query latency. So query latency is quite critical. People don't get search results back quick enough. Question? Can you export the graph easily enough? There is no export function, but all of the data is in the WSS login DB. So you can pull the data out yourself and generate your own reports. So it's very possible, yeah. Query latency is important, not only from a traditional search perspective in terms of how soon do my results come back, but if you're in an environment that's very heavily or has a lot of very critical web content published information, delivered by SharePoint Search through content by search web parts, for example, you really want to make sure your query latency is low. There was a question yesterday in one of the sessions about the content by search web part, or there was a statement, sorry, about the content by search web part not being available in Office 365 yet. Okay? There's a reason for that, because we've no idea what it's going to do to the query latency. So slowly but surely, we'll make that content by search web part available. We'll start off with one subscription plan. We'll enable it for certain capabilities, maybe public sites, maybe intranet. Then we'll move on to the next one while we develop an experience for how it's going to behave. There is no test environment if you consider Office 365 and the size of it. Office 365's got in almost 1 billion items in Office 365 search index, multiple search service applications, right? You can't build a test environment that large. It's just not possible. So the only way we can find out how these things are going to behave and how the experience is going to be is to turn them on slowly. As Victor was mentioned earlier, turn something on, test it, see how it behaves, expose it a bit more. But we can't just turn it on carte blanche and see what happens. Certainly not in an environment that large. So query latency becomes critical. Knowing how well your query servers are performing. And from SharePoint perspective, we want to deliver all search results less than a second. So when you start to look at the things that queries are doing, from a query latency perspective, we want to make sure that our individual queries, so if I just go back to this one, a bit hard to see. If we look at, you've got two things here, we're looking at object model and backend. So if our queries are very slow, very highly latent, we can start to drill into, well, why are they latent and where's the bottleneck? Is it at the presentation of results to the end user? Therefore, we need to look at configuring our result sources or our display templates differently. Is it in the security trimming side of things? Therefore, we need to think about, has our query processor got enough horsepower? Do we need to have more query processors to serve additional queries per second. So you can start to drill in using these results to find that information. The other one I wanted to show, I think, was this one. Yeah, so if I just zoom in on this and get the dates right, the 12th at the 12th. Please shout out if you think I'm getting the date wrong, because I don't want to do that again. Let's go for 11 p.m. and 12. Okay, what have I done wrong? Oh. Oh, okay. No, that's right. End date. Oh, okay. Nope. Yeah, sorry. I've done it wrong again. Let me go back. Query reports. See, it's not easy. 12 a.m. and 11 at... I'm losing my mind here. I can't see what this is. Anyway, I'm going to leave it because something's gone wrong. Well, I'm going wrong. But you can see the data you get at the bottom. Keyword parsing, linguistics, recommendations, and security trimming. Basically what it's doing is that previous report that showed you back-end or front-end, as in query results versus back-end processing. This one takes it one step further, and you start to see things like you can start to see where in this whole security process the problem is. So if it's index lookup, for example, if I had a huge orange spike showing a high number of milliseconds, I want to start looking at my actual on-disk indexes. Have I got enough replicas to surface the amount of queries per second that my end users need? If I've got enough replicas, then that's fine, but do I need to think about, are my replicas now suffering from CPU issues? Am I getting throttled due to CPU, throttled due to disk or memory issues? So it allows you to really drill in. And the only real way to kind of experience what this is like is to go and find a really poorly behaving environment and try and fix it, such as this one. Okay, how are we doing for time? How much time have I got? I can't remember where we started the session. We're almost done, aren't we? Okay, I'll flip back to the slides very quickly, and I've got a few. Am I over? All right, well, I always go over, sorry. So the last couple of slides, and then I've got some swag to give away. Most of the last set of slides, there's about 10 slides at the end of this deck, which I've included purposely for reference, because they don't make an awful lot of sense in terms of a presentation from a straightforward how to deliver this stuff. They're really for reading references. Key things I wanted to call out was things like crawler, content sources, some of the new features. The ability to do anonymous crawling is new in 2013. The continuous crawl we've mentioned already. Things like async rendering, so content web parts that might be, for example, security based on an end user's view of the world, if you like, from a SharePoint perspective, or audience targeted web parts. The SharePoint engine is able to asynchronously render those and gets a view of those web parts, so we're not losing the ability to crawl content anymore. Crawl targets, Victor mentioned earlier about using request routing. Other things we can do is obviously through PowerShell we can configure the crawl targets, and we can do host file manipulation, which is probably the most common way to do crawl targeting these days. The one thing I really wanted to call out on the last set of slides, like I said, the rest of it's really reference, is this concept of reindexing. So we mentioned earlier about the ability to do, if I change something in a document library, what if I go and add a new column and I want to expose that column as a crawl property? I can go in through 2013 now and issue a request as a user or a site admin to recrawl that entire list. The old way of doing it was to go into the list and exclude it from search results, wait for a crawl, add it back to search results, wait for a crawl, and you were good. Now you can just go in and click these buttons. So as a site admin, I can go recrawl my entire site. And then the next time a crawl runs, even if it's incremental for everything else, it will full crawl your site on request. That's a huge new change. It's a massive change in the product, and it makes the ability of a site admin much more flexible. Like I say, the rest of the slides are really for reference. And things like linguistics is really, Wayne's going to talk a little about this, so spell checking, like I said, reference only really. The whole subjects of these individual slides are really quite complex, and there's a lot of work to do to get into them. So I've really just, like I say, included them for reference. So if I'm over, I'm going to stop. And any other questions? It's a huge subject. I'm sorry, it just takes a long time.
Basically, in 2010, the full crawl versus the incremental crawl, you do the full crawl initially, and whenever you make sort of a major change to your content or manage properties. In 2013, does the role of the full crawl change in any way? Also, what's the impact? Does the continuous crawl pick up some of those changes that we previously needed a full crawl for?
So the full crawl remains more or less the same in terms of what it actually does. It reindexes everything, okay? There are some things, such as if you make a managed property change at a global level, then a full crawl may well be required. Or equally so, you know, if you change something in a list and hit that full crawl my list, then it will pick up those changes. The impact of a continuous crawl, the continuous crawl has some limitations in terms of what it can do, like things like retry, as I mentioned already. But it will discover new list items, new changes. So if you imagine most of these changes are driven towards the O365 tenant admin, right? So we don't want to be going kicking off entire full crawls just because you need a new managed property. So as a tenant admin, some of the other things that Wayne's going to look at later is you can modify the search schema in terms of managed properties and crawl properties at the tenant level, at site collection level, and at subsite level. So the full crawl is not necessarily needed for all of those things anymore. The continuous crawl and the incremental crawl will pick those up as well. Okay. Middle, sorry. Yeah.
For the continuous crawl, you mentioned that it was quite like labor intensive. Is there any way to kind of limit the amount of crawls that you run at once, just in case there were a lot of changes?
So the way to limit the number of crawls that run in parallel is to really to reduce the frequency. Yeah. So if you reduce the frequency to every, say, 30 minutes, then in theory, as long as you didn't get a continuous crawl that overran a long time, you would throttle back. But the real way to control crawl is really around the impact of a crawl, is using either crawler impact rules, which modify the number of threads available to the crawler, or, like I say, timing will work, and you can do some other things with PowerShell to change what we call the performance level of the crawl as well. There's a number of ways to control it. Okay, that deserves a ticket. That's a good question. Question over that side? Cheers.
I was just wondering, can you get the search to search external things like external database or external directory or something like that?
Absolutely. So the search engine has support for BDC connections, and the BDC framework is the new way to crawl custom repositories. So as long as you can create a BDC model for it or a custom connector for it, you can crawl it. Yeah, it might be up to you to decide what the security trimming is like, and what the data model looks like. But in theory, you can crawl almost anything. Okay, there was another question over there.
Yeah, so you mentioned earlier on about user queries now being added into the context of search. So does that mean that if we have multiple users with a similar or same query opening, for example, a particular document, that can be prioritized in terms of response from the engine?
In many respects, yes, in a way. So what happens is, the more people open a particular document, specifically if they go to that document via a keyword search in search, if that keyword constantly drives people towards the same document, the next time someone searches for that document, there's likely to be a recommended link that says, we're recommending these items based off what you're searching for. And it has an impact on things like ranking and weighting. It also has an impact on DR, because you can lose a lot of that kind of search analytics, if you like, as a result of DR. So, other one.
Is there any way in 2013 to hide some of the search content?
Hide in what regard?
What's being displayed in search?
So
you run a search, you run a crawl, etc.
okay, so let's say we've got a search, we index our entire search service application, our entire web application. We want to exclude certain things. So yes, that you can do crawl rules, which allow you to specifically exclude either certain URLs or certain anything you can describe with the URL, including using wildcards and regular expressions. you can do that to exclude content. Absolutely, yeah. Yes, so Wayne's going to cover search dictionaries. A lot of the back-end stuff is going to be covered by Wayne, which is why I left it in for reference, really. When I realized Wayne was going to cover it, I didn't think I needed to go into any detail. So, last one.
I guess just in terms of performance and that, you've got like web front end and an app server and SQL. So can you sort of adjust I don't know, put it to your chart, you've got 3 stars on each thing, so adjusting some of the crawls to the web front end and then to the application server. Is there any way you can sort of do the analytics as well, to schedule that at night time or something where it's a little bit quieter?
So the core analytics processing job is timer job based. So you trigger that with a timer job. So you can change that. And typically, I think default it runs at 1 a.m., if I remember correctly. There is the kind of event processing, there's some of it that happens every time you do a crawl. Typically, you can tweak it. Like I say, the main one, the most impactful one is the one that runs with the timer job. But other things like there's a continuous kind of processing of events all the time. So when I'm building a dev server, for example, I always turn analytics off because it just slows everything down. But yeah, you can tweak the timer job. That's probably the key way to do it. Question?
Is there a utility that you can probably set up to provide some sort of alerts to inform you about any problem on the search?
Yes, that's a good question.
Visual report.
Yep, so we got the reports, which means the user has to go in and look, or the search admin has to go in and look. You just won yourself this, by the way. That's a great question. The other thing with search is there's approximately, I think, depending on how you deployed your components, there's hundreds, if not totally thousands, of performance counters that you can create alerts against. So in 365, we have an enormous SCOM-based implementation so that all it's doing is measuring search. And we also, as part of that SCOM deployment, we have custom PowerShell queries that are running all the time measuring search metrics. So we're not just relying on going and looking at the graphs. We do it through a sensible way. And there was a question earlier in Victor's session about using SCOM to measure SharePoint. Absolutely for search as well, yeah. You can have this if you like. Yes. So it isn't turned on by default, but it is turned on as soon as you enable search. That service application, the WSS usage provider, if you try and deploy search by itself and you haven't turned that guy on, you will get that guy deployed. Well, it will. The action of creating a search service application will turn that on for you. Yep. Now there is a search provider that you can disable or re-enable. Sorry, Whit, I'll get you in a second. There is a search provider inside the WSS login configuration that you could turn off if you wish. Then you'll lose all that data. So you don't necessarily have to monitor it, but you need the WSS usage application. Yeah. It's not a good idea to turn that off if you want to make use of analytics. Oh, sorry, make use of metrics and data in SharePoint. Okay. Any other questions? Well, I can hang around. I'll be around for ages. I know I overrun, so I do apologise. But if you've got any more questions, come and shout out. I'll be around all day. You can have a big robot. Cheers. Thank you.